This is the lesson video for 3-5. You'll also use this video to check your day of homework from 3-4. And eventually, after you complete the 3-5 homework, at the very end, you can also check the covered up ones from the key. Be sure you're pausing the video at different times, taking notes, doing the practice it calls for, and giving this some thought, using the construction site that has the videos as well to help support your learning. So in 3-4, you had a few covered up, so pause the video here, be sure to check those. In 3-5, the goal is to be able to use the 4 constructions that you already know, and they're listed here, in order to take known relationships and build other items. You've built squares and rectangles by construction using those 4 already, and now you're going to continue to do that. So it brings in the deductive reasoning and the properties with your constructions as tools, and the reasoning belongs to how you're going to make those simple tools do something bigger. So we want to think about all the relationships about parallel lines that we know. If our goal is to construct parallel lines, we have to think about, well, we've got its definition. The definition of parallel lines says that we would have to form 2 lines on the same plane that never intersect. And we could eyeball that, but we can't construct that, meaning we can't know that those won't happen unless we use some other properties to make that happen. So the definition won't help us much with the construction. It tells us what they'll look like when we're done, but we're going to have to come up with some other ways to do that, to make that happen. So if you were to go to your notebook, you have 2 properties that mention parallel lines. One of them is the parallel lines conjecture. The challenge we'd have in using that is it needs us to already have parallel lines in order to use it. The converse, however, does not. The converse ends that if we do certain things, then we get parallel lines. That's exactly what we need here then. It says if we could make a set of corresponding angles that were congruent, or if we could make a corresponding set of alternate interior angles that were congruent, or, and it is an or, we could make a set of alternate exterior angles that were congruent when 2 lines are cut by a transversal, then we'd know for sure we had accomplished our goal. And constructing angles the same size as other angles is a task our constructions already can do. So that's the task we're going to take on. How can we use this knowledge that we can get congruent angles in order to form lines that are definitely parallel? So in the bottom corner, I've got an idea. I'm going to start with some 90-degree angles because I happen to know that we're really good at making 90-degree angles, and that if I make 2 90-degree angles to a line, those 2 new lines should be parallel. So in doing that, try this construction out. I'm just going to start with 90-degree angles. We're really good at those. So I'm just going to pick any 2 places on this line that I'm going to construct a perpendicular bisector between so that I get some perpendiculars going. If I had to be more specific about where the parallels needed to be, then it would be. So first I'm just going to get a good compass swing, make sure this is going well. Notice I'm not choosing where on the line very carefully. I'm just picking any place. And between those 2 places, I'm going to construct a perpendicular bisector. Now that I have the points to form one line perpendicular to my original, I would know for sure that anything else I make perpendicular to that purple original line would also be parallel to that new black line that's been formed. So I'm just going to, again, pick some places on my line here since I'm not doing a specific set of parallels. I'm going to pick some places on my line and do a perpendicular bisector construction so that, again, I get 2 points equidistant from those endpoints that I'm choosing. And with my perpendicular bisector construction, put in that last line. You know, I first have to just draw a line and then move it on the smartboard, but you obviously should be connecting 3 intersections. Here's what I know, so that this will match the picture. Lines K and lines L fulfill the idea that if I checked their corresponding angles, they would be congruent. Or if instead I checked a set of alternate interior angles, they'd be congruent. Or if I checked a pair of alternate exterior angles, they would be congruent with the purple line serving as my transversal. So I don't need to mark those. This is the part that guarantees I have those angles duplicated and they are congruent, therefore my lines must be parallel. Now we want to see if we can try that idea, but with some non-parallel lines, with some non-90-degree angles, some non-perpendicular lines. So again, still using that converse of parallel lines conjecture. We're going to do a few of these. I included the constructions later, but some are also your tasks and homework to pick one set of those types of angles. Alternate exterior, alternate interior, corresponding angles, and if you form them congruent, then your lines will be parallel. So our goal is going to be to make a line parallel to line L. And therefore, line L needs a transversal coming through it. The transversal can come through at any angle. So with your straight edge, you would simply make a transversal coming through that original line. I'm going to color my transversal green just so that we know that that's the one that's serving as our transversal. You don't need to do that. At that intersection then, it's a lot like what I have here. I have 4 angles formed. And if I decide that I'm going to duplicate any one of those in a particular place down the transversal, and you can just pick a point for now, unless that point was specified in a problem. If that point was specified in a problem, you'd want your transversal to go through it. At that point then, I want to duplicate either angle 5, 8, 6, or 7, and think about where that's going to go. So I'm going to start by doing a pair of alternate exterior angles. So I'm going to choose at my picture. So I'm going to use the idea of constructing a pair of alternate exterior angles that will be congruent. We just did the 90-degree angle idea, and any of those could have been the angles. So I'm going to choose the angle in my idea right there at 6 in my diagram. So this is my plan, if you will. We said it's often good to have a blueprint or a plan. Therefore, if I want to duplicate a pair of alternate exteriors, at the intersection point I have on mine that's green, to make this match my plan, I'm going to duplicate angle 4, congruent to the angle 6 that I already have. So I'm going to take a moment and extend a few things here to make this construction go a little bit better. Slide my line over a little bit, or just extend it with a straight edge, and move the label out of the way. So first things first, with my compass, I need to put an arc through the original angle I'd like to duplicate. So here at angle 6, down in the part right here, bring my compass in a little bit, change the color of my arcs. I'm going to swing my compass once at that angle 6 location idea. Then I'm going to come up and I really need to swing that right here where I believe I'm going to put angle 4. And I've got to estimate a little bit, so I'm going to go underneath and up above, so that my arc is there, about where I believe angle 4 is going to go. Then I need to do a little bit of checking of the distance between the 2 points that I'm interested in duplicating. Let me slide up a little. So between this point and my compass and round it out a little bit. This takes a second on the smartboard compass, so forgive me. You get a moment then to catch up. So I'm checking that distance between my 2 intersection points, and coming up to that same intersection on the original, on my new, swinging that arc to mark off the exact same amount of arc in one place that I have in the other. That new intersection point that I just created, from the vertex through that point is where my line is going to go to complete my angle. So starting here out through there, again with your straight edge making that longer. And because I duplicated a pair of alternate exterior angles, these lines must be parallel. So on this page, I'm going to slide down on the video so you can see it. I'm showing you what it might look like if you constructed a pair using alternate interior angles, what it might look like if you did a pair of corresponding angles, and what it might look like again if you did a pair of alternate exterior angles. And you can review and move the video to where you need to. Your task then in 3.5 is the problem shown. Suggest that you make a sketch first of what you're trying to accomplish to help your brain follow that plan. Check that your vocab and properties notebook is updated. And after you finish 3.5, then you'll come back and freeze the end of the video here so that you can check your number 3 and your number 7.